Hey everyone, this is a geometry video going over the homework for Unit 10 lesson, I believe it's lesson 8, the volume of prisms and cylinders, right? Yes. So I figured a good way to start is just to go over the homework and we'll go from there. So hopefully this is helpful. Alright, so question 1, the following wedge prism has a volume of, so I don't know if he mentioned it, but basically for volume of any prism, you take the area of the base, which we very often use capital B as area of the base, and then times the height of the prism. So if you can find the area of the base, and you know the height, you can then find the volume. Here's what I mean by that. So in this case, this right triangle is the base of the, they call it a wedge prism, triangular prism if you want to call it that. So to find the area of a triangle, you have to take its base, so 4.5, times its height, which is 2, and then divide it by 2. So 4.5 times 2 is 9, and 9 divided by 2 is 4.5. So this has an area of 4.5 square inches. To find the volume of that, we take the area of that, so 4.5 square inches, times the height. So 4.5 times 6. Do that on a, so volume equals, and you're going to get 27 cubic inches. Right, so number 2, a right circular cylinder with a diameter of 14 inches and a height of 10 inches has a volume in cubic inches. What of which of the following? Oh, so what is the volume? Now, first of all, why it's called a right circular cylinder is because it basically hits the ground at a right angle. So basically, it can sit on a table and not fall over. Here's something, it's a cylinder, but it's not a right cylinder, kind of a tilted cylinder. So that's right circular cylinder, not right. In any case, so we're not dealing with that one, we're dealing with this one. Alright, so what I'd like to do is look at it from the top. So think of this as the top view. We know that this circle has a diameter of 14. And just like I said before, if you find the area of the base, and you might say, well, that's the top. Well, flip it over, it's the bottom. So, if we find the area of this circle and multiply by the height of this cylinder, we'll get the volume of the cylinder. Now, to find the area of a circle, we need the radius. If the diameter is 14, the radius is half of that, which is 7. So I'm going to use the radius of 7, plug that into pi r squared. That's the area of a circle. So area equals pi times 7 squared. And if you didn't notice, the choices are all in terms of pi. So I'm going to leave this as 49 pi. Now that's the area of, of the circle. The volume would be the area of that times 10. So the volume would be 49 pi times 10. Now you could do that on a calculator and get a decimal answer, but you can see our choices aren't decimals, they're in terms of pi. So we're going to do the 49 times 10, which is 490, and then times pi is just times pi, so that would actually be choice number 2. Right, now for this next one, a box tube is to be constructed out of 1 centimeter thick metal that has a width of 10, a height of 6, and a depth of 15 centimeters. Which of the following represents the volume of the metal used? So basically this is a prism with a prism removed. So what I did is I first found just the volume of the whole thing as if there wasn't a hole in there. So the volume of that would be, let's call this the base, so 10 by 6, 10 times 6, times the height, which is 15. So the volume equals, that's 60, and 60 times 15, I believe, is 900. So the whole thing without anything removed is 900 cubic centimeters. So now let's talk about the piece that was removed. So a centimeter was taken off of the top, a centimeter was taken off of the bottom, and a centimeter was taken off of the left and the right. So these two measurements here and here are going to be reduced by 2 each. Okay, again, left, right, top, bottom, minus a centimeter each of those. So if it's 10 this way, then it's going to be 8 centimeters that way. If it's 6 this way, minus 1, that makes the inside piece 4 centimeters. So the volume of the piece that was removed is an 8 by 4 by 15. So 8 times 4 times 15, I believe would be 480 cubic centimeters. So we want the volume of the metal used. So the whole thing was 900. We're taking out 480, and that will leave us a volume of 420 cubic centimeters, tee 420. Okay, and the next one, pretty complicated. A large plastic bucket is in the shape of a right circular cylinder with dimensions shown below. If there are 1,000 cubic centimeters in a liter and 3.785 liters in a gallon, then which of the following is true about the volume of this cylinder? So, first, why don't we find the volume in cubic centimeters? So, again, what I would do is find the area of the circle at the bottom. It tells us that the radius is 15, so pi times 15 squared. And for now, I'm going to leave that just as 225 pi. Just for now. So the volume of this would be 225 pi, the area of the circle, times the height of the bucket. So 225 times 28. I didn't do that beforehand, so 225 times 28. 6,300. I don't know if you can see that. 6,300. Yeah. Anyway, it's 6,300. But it's times pi. Right, so that's the volume of the bucket. But that's in cubic centimeters. So, to change that into gallons, we're going to change cubic centimeters into liters. So we're going to do a couple of proportions. So proportion, line, equal sign, line. We're going to do cubic centimeters to liters. So it tells us in the problem that there are 1,000 cubic centimeters in 1 liter. Well, we have 6,300 pi cubic centimeters, so how many liters? Right? So that's the proportion, and we're going to solve proportions by, one way to do it is to cross multiply. So we get 1,000x is equal to 6,300 pi, divide by 1,000, and we get 6.3 pi, and then that would be the volume in liters. Right, we could find the decimal, but I'm going to, again, leave it in terms of pi for now. All right, next we need another proportion to turn liters into gallons. Okay. So line, equal sign, line, we're going to change liters to gallons. Liters to gallons. It tells us here that it's 3.785 liters per 1 gallon, and we have 6.3 pi liters here. So how many gallons? I'm going to call that G. So again, we're going to cross multiply. We get 6.3 pi is equal to 3.785 G. So the gallons, I'm going to type this all into my calculator. So let's see here. Does that help? A little, yep. All right, so I'm going to do 6.3 times pi. Then I'm going to divide by 3.785. And I get 5.229. So let's say about 5.23. So about 5.23 gallons. So which choice makes the most sense? It is less than 1 gallon? No. It is between 3 and 4? No. It is between 5 and 6? Yeah. All right, so the key there was to set up those, I don't know if it was a key, but okay, setting up and solving those proportions to convert measurements. Maybe that's something we'll look into later on. Okay, moving on to number 5. Number 5, we have a piece of hardware is constructed by drilling a cylindrical hole through a right prism with a square base. Notice that it says square base. Let me zoom out just a little. That measures 20 millimeters on each side. The hole is 35 millimeters long, as shown in the diagram. Determine the volume of the remaining material once the hole has been drilled. Round your answer to the nearest cubic millimeter. So we've got two things. We've got a square prism and a cylinder that we're removing. So what I would do is, again, it's a square down here, so the area of the square, I'm going to find the area of the base, is 20 times 20. So that's 400. The volume would be the area, which is 400 times the height of the prism. So 400 times 35 is 14,000 cubic millimeters. All right. So then the cylinder, so if this is our 20 by 20 square at the bottom, it looks as if the circle kind of goes like this, so that the diameter is also 20. Now let's not worry about, well, if they cut right to the edge, what's left, but theoretically nothing. But anyway, let's go with it. Now to do the area of the circle, we need the radius. Well, if the diameter is 20, the radius is half, which is 10. So let's do the area of the circle, pi r squared. So I'm going to replace the r with 10. And right now I'm going to leave it in terms of pi. So that's 100 pi. Now to get the volume of the cylinder, we're going to take 100 pi and multiply times the height, which is 35. So again, leaving it in terms of pi, we got 3,500 pi cubic millimeters. So finally, to figure out what is left, okay, so the volume of, let's call it remaining, or just remain, we're going to take the 14,000 cubic millimeters of the right cylinder, the square cylinder, sorry, subtract the 3,500 pi cubic millimeters of the cylinder, and it does say to round to the nearest cubic millimeter, so let's do that on, we got 14,000 minus 3,500 times pi, and that's going to give us 3004.4, which rounds to 3004 cubic millimeters. Okay, number 6. All right, so again, to find volume, we need the area of the base. So this is our base, this equilateral triangle. It tells us right here, equilateral triangle. So all sides are the same. So let's just look at the front view here. In fact, let me make it just a tad bigger. You'll see why in just a second. All right, so 10 on each side. All right, now to find the area, because again, to find volume, you need the area of the base. To find the area of a triangle, we need its height. So we actually need this. It's called an altitude. All right, so to find that though, that's going to split this into 5 and 5. So it hits the midpoint here. All right, to find that, we're going to actually use the Pythagorean theorem. So we're going to use 5 as a leg. The hypotenuse is, again, it's opposite the 90-degree angle. The hypotenuse is 10, and so we're going to find this by doing, now to kind of keep it simple, I'm going to take the hypotenuse squared, and instead of adding, I'm going to actually subtract the 5 squared. All right, so I get 100 minus 25, which is 75, and then I'd have to take the square root of that. So this is actually, and I'm going to leave it the square root of 75 for now. Okay, so the height is the square root of 75. So to find the area of that, we're going to do the triangle's base. So this whole base here is 10 times the height, which is the square root of 75, all divided by 2. All right, so what I'm going to do here is, let's get a decimal. Let's just work with a decimal here. So 10 times the square root of 75 divided by 2. Let's do 43.3. 43.3. All right, now if we take that and multiply by the height, which is 30, we should be able to get the volume. So 43.3 times 30, 1,299, and it says round to the nearest cubic inch. So it would just be 1,299 cubic inches. So the difficult part there was finding this height, or this altitude of the triangle, by using the Pythagorean theorem. Okay, going on to the last one. Something that only gets tested once in a great while, and that's something called Cavalier's principle. Basically, what Cavalier's principle says is that, maybe, I don't know if this is going to look weird, but if we have what I did is I have a couple of triangles that I'm stacking to make a prism-like object. Cavalier's principle is basically saying this stack of triangles has a certain volume, the area of the base times the height, and even if we tilt it, oh boy, it's going to still have the same volume. So basically, let's say this has a volume of 3, so does that. Well, anyway, you get the picture. Basically, tilted has the same volume as untilted, as long as they have the same height. Now, what I would do with this one, it does say that B, C, and A all connect midpoints of sides. Let's just take a look at this bottom edge here. Or I shouldn't say edge, this bottom side face. Now, they don't give us numbers, so let's call it, that's the midpoint B, that's midpoint C, and then it looks like it goes something like this. So we have a right triangle as the base here. Right, now, it's asking, explain using Cavalier's principle. So even though it's tilted, it's going to have the same height. Right, so whatever that height is, it's going to have the same height coming down, making a 90-degree angle with the base. Why the volume of the shaded region must be 1/4 of the volume of the original rectangular box. Well, if you look at this picture, this triangle that's at the base here, so again, we're looking at this one, but from the top view. So, okay, if you think about it, that has 1/4. So here's a fourth, here's a fourth, here's a fourth, here's the fourth. May the fourth be with you. It has 1/4 of the area of this base. So if you think about it, the volume of the rectangular box would be whatever the area of the base is times the height, whereas this would have 1/4 the area of the base times the height. So the area of the base of the shaded region is 1/4 that of the area of the entire base, so the volume would also have to be 1/4 of the volume of the whole prism. Cavalier's principle comes up, I think I've seen it maybe 3 times on all the tests, so it's not tested too much, and that's, if we have tests. I don't know anything yet, but just saying, we'll see what happens. Alright, so that was the homework. Hopefully everyone's doing alright. Hang in there. Hopefully that was a help.